Dear students, today we are going to discuss assembly language program of 8051 microcontroller. Today we are going to implement the half adder logic. Okay, so this is your half adder circuit. Here you can see two input A and B. This is your sum and carry. This is your truth table. Okay, so this is the input and this is the output, sum and carry. Okay, so in microcontroller I am going to assign 0.1 port 0.1 for first input A, going to assign port 0.0 for your second input, this B. So you are aware that you understand that in port you have a 4 ports, right? In every port you have a 8 pins, so that means the range vary from 0 to 7. So the first pin is port 0.0, second pin is port 0.1, and next pin is port 0.2, and next pin is port 0.3, 0.4, 0.5, 0.6, or 0.7. okay, here, so one input is connected in this port in specific pin. Similarly, another input is connected in port 0.1. So sum is connected in 2.1 and carry is connected in port 2.2. So these ports are specified in the program. That's why we are assigning. Okay, you can observe you have a two output, sum and carry. The carry logic is performed with the logical AND operation. The sum is performed with the XOR logical operation. So for doing the AND logic, so in 8051 microcontroller you have a bit oriented instruction, but for performing this XOR there is no specific instruction. There is no bit oriented XOR based instruction. Okay, so you need to perform with the byte oriented instruction, but it work with the bitwise, but it operate on your entire bytes, that is 8 bit. Okay, so but we are interested in the least bit. Okay, so that specific bit you need to check that you need to transfer to the accumulator. Okay, so repeating again, to do the XOR operation there is no bit oriented XOR instruction in 8051 microcontroller. So you need to perform with only byte oriented instruction, but this byte oriented instruction it operate in bitwise but operate on entire byte, that is 8 bit. Okay, but it operate at the bit level. Okay, so that is important to remember before you start to write the program. Okay, so first what we will do, so parallelly I will put the table for your better understanding. Okay, so this is the first instruction of the program. So first what we need to do is like a 2.0. So clear the bit port 2.0 and set to 0. That means the port 2.0 will be 0, right? Similarly, the third instruction, the 2.1, it will clear the bit port 2.1 and setting into 0. That means port 2.1 also will be 0, right? Then the fourth instruction, set B 0.1. That means set the bit port 0.1 to 1. That means this port 0.1 now it will hold the value 1. Okay, similarly set the bit 0.0 to 1. Okay, So that means what I am doing is I am clearing the bit, the 2.0 and 2.1, and I am making this 0.1 and 0.0 as the input ports. So you can see here, so I am configuring this 0.1 and 0.0 and 0.1 as a input ports and the specific pins. Okay, so that's what I am doing here. Okay, now the content of port 0.0 will be transferred to C. So that means C will be holding the value of 1. Right. Now, while coming to this instruction, what we are doing is we are performing the logical AND operation between C and port 0.1. Right. So C hold the value of 1 and your 0.1 hold the value of 1. So if you do AND, so you can see here two table. If you do AND for 1 and 1, you will get the output 1. Right. So that value will be saved in here C. Right. This is the output after doing the AND logical operation. Okay, that is after this 1, 2, 3, 4, 5, 6, 7th instruction. After execution of the 7th instruction, your value is 1, the carry bit. Okay, let's see. Now the content of C is 1, that is moving to 2.0. So 2.0 means what? Carry. So what I assumed here is 1 and 1. I am giving two input, 1 and 1. The carry is 1. So that's what we obtained here, right? The carry is 1. So that means we perform the program, return the program properly. So this is for carry. The carry is over. Okay. Now we need to write the logic for sum. Okay. So to do the sum, so what as I said earlier, here you need to do the XOR, but there is no bit oriented XOR instruction in 8051 microcontroller. You need to perform only with the byte oriented instruction. Okay. So first what I am trying to do is move whatever content in the 0.0, that is transferred to C. Okay, whatever content in the port 0.0, that is going to C. That means you can see the content of 0.0 is 1, that is 1. Okay, now jump if carry is set. Okay, so if then condition is true, because you know that the C will hold the value of 1 now. So the condition is true, then I need to go for input 1. Suppose if condition is false, if C is 0, this condition fail, then I need to send 0 0 to the accumulator. Now condition is true, right? Then I need to go to the input 1. So now what I want to do, I need to transfer 1 to accumulator. Now accumulator will hold the value of 1, right? Then short jump back 1. So you need to back 1 label. So this is a label, right? Want to come here. So here what I am doing, the content of 0.1. What is the content of 0.1? The content of 0.1 is 1, right? So I need to transfer to C. So that means C will have the value of 1. So now again I need to check. So jump if carry is set. So condition is true. I need to go to the label input 2. So I am going to the label input 2, and what I am doing, the 0 1 I am transferring to the register R0. Now R0 will hold the value of 0 1. Then you go back to short jump, back to the label, back to, right? I am going to the back to. Now you need to perform the XOR operation, logical operation between A and R0. You know that A hold the value of 0 1, R hold the value of 0 1. Now you need to perform the logic. You know that it's a byte oriented instruction. Okay, so it will process only for entire 8 bits. Okay, so it will be like this, right? So 1 1. So what do you mean by 1 1? 1 1, if you do the XOR, this is the XOR truth table. If you both the inputs are 1, output will be 0, right? So others are 0 0 0 0, but we are interested only in this bit. There is a least significant bit, right? So that I can take it as a accumulator, that is a 0th bit, that is your least significant bit, right? That is your least significant bit of accumulator. Okay, so this bit only interested, that value that is moving to the carry bit C. Okay, that value again I am moving to port 2.1, because port 2.1 you are assigned for the your sum. So what is the value? If I am giving 1 1, your value will be 0, right? So you can see here, so I gave 1 1. Okay, so you got a 0. Okay, so this is the output after doing XOR logic. This is the output after doing AND logic. So here the value is moved to port 2.1 and short jump end 1. So end 1 is a label. Here you return the program, right? Here. So here no operation and end the program. So this is a way to write the program for half adder. Similarly you can try for full adder also. So here only logic is you are using AND logic and XOR logic, but please remember, for XOR logic there is no bit oriented XOR instruction in 8051. You need to perform only with the byte oriented instruction. That is one important thing you need to remember in this program. Thank you.